Hello friends, welcome to Learner's Tube. In our previous video, we have discussed about Lami's theorem. If you have not watched it yet, please watch it. The link is provided in the description box. In this video, we will discuss about resolution of force. What is resolution of force and how you can resolve a single force into multiple forces. That means a single force into two directions. In the previous video, we have discussed about resultant of the force. So you must know what is the difference between resolution of force and resultant of force. Resultant of force is nothing but making or combining multiple forces with a single force. That means the effect shown by both forces will be shown by a single force, that is called resultant of force. Now, what is meant by resolution of the force? The opposite to the resultant of the force. Resolution of the force is nothing but a single force is resolved or divided into two forces or three forces in three directions. For example, in a plane we have x, y and z directions. Just for now, consider a plane with x and y directions. If you have x and y directions and there is some force, you can resolve this force F into two forces. One is along x direction and another is along y direction. That means name it as Fx. Other one is Fy. That means the F component along x direction, the force component along y direction. That is called resolution of the force. Now can you understand the difference between resolution and resultant of the force? The resultant of the force is nothing but combining two forces into a single force. Resolution of the force is nothing but resolving. Name itself indicates resolution, resolving. Resolving a single force into two forces. One is in x direction, another is y direction. The effect shown by this single force is equal to effect shown by both the forces combinedly. Okay, this is called resolution of the force. Now, how we calculate the resultant of the force? By using parallelogram law, right? By using parallelogram law, we can make the resultant by doing two forces. Similarly, in the resolution of the force, how we will do is, observe this figure. If this is x axis and this is y axis and this is a force R. Now we have to resolve this force R in two directions, that is x direction and y direction. So as this is x and this is y and this is R force. This R force is making an angle theta with x axis. You have to observe whether the theta is inclined towards x axis or y axis, because if I consider theta here, the value changes. So theta is nothing but angle inclined by R with reference to x axis. Okay, this is angle theta. Now, to resolve this R force in x direction, what you have to do? Drop a perpendicular from R to x axis. Okay, I am naming it as A. Now, as this is a right angle triangle, I know the value of hypotenuse. I want to calculate the value of base. So, which angle you will prefer? Adjacent side to the hypotenuse. So, which you prefer? Cos theta. What is meant by cos theta? Cos theta is equal to adjacent side by hypotenuse. That means cos theta is equal to OA by OB. Okay, observe here. Cos theta is equal to OA by OB. So we have to find out what is the OA value. As OA is in x direction, I am naming it as Rx, which is nothing but R suffix x. That means component of r in x direction. Okay, similarly in y direction I am naming it as ry, that means component of r in y direction. Okay, now OA is nothing but equal to Rx. OB we all know, that is R force. So cos theta becomes Rx by R. So what is the component of R in x direction? R cos theta. Similarly, to calculate in y direction, I am considering the sin theta value. It is theta, it is R. Sin theta means opposite by hypotenuse. What is the opposite? Side AB. So sin theta is equal to AB by hypotenuse OB. We know AB value is nothing but the component of R on y direction. As it is a rectangle, opposite sides are equal. So AB is equal to this component, which is nothing but Ry. So Ry is equal to R sin theta. Okay, there is a shortcut to remember. We don't need to calculate all this. There is a simple shortcut to remember this. Take any force R, observe the theta side, which side theta is there. Along that side, component of R is R cos theta. And in the absence of theta, which side the theta is absent? See, this side is theta. So this side becomes R sin theta. For example, if it is R and it is theta, then this becomes R cos theta and this becomes R sin theta. The component which is along the side of theta, that becomes cos. The component which is opposite side of the theta, that becomes sin. This is a simple shortcut to remember this. No need to do all this calculation. Okay. Now you can resolve a force into two components. What if there are multiple forces, more number of forces? What you have to do? Simple. There is not much difference. Simple. If there are multiple forces, you are adding all the components. Okay. See here. This is force R1, this is R2, this is R3. R1 makes an angle of theta 1, R2 makes an angle of theta 2, R3 makes an angle of theta 3. All the angles are with respect to x-axis only. You should not consider like this, then it will go wrong. See, if I consider it is theta 2, only this part is theta 2, only this part is theta 3, then this is not applicable. You have to make the angle in such a way that all the angles are with reference to same axis only. For example, it is theta 1, it is theta 2, it is theta 3. All the angles are with reference to x-axis only. Okay. Now, what is the horizontal component? That means if three forces are acting, there is definitely a resultant force which make all the three forces into a single force, right? For example, resultant force may be somewhere here. What is the component of this resultant force in x direction and what is the component of this resultant force in y direction? Means you just summation of all the components, x components of all the forces. That means first resolve all these three forces individually. It is R1. So for this R1, x component will be R1 cos theta 1. For R2, x component will be R2 cos theta 2, as the angle made by R2 with x-axis is theta 2. For R3, it is R3 cos theta 3. Because the angle is here is theta 3 with the x-axis only. Okay. Now, if you do the summation of all the three components, which gives the component of R, resultant force R. Okay. Now you can get doubt. Already three forces are resolving. Why we have to combine all the three forces into single force? Again, why you are dividing that single force into two directions, because while analyzing a analyzing a problem, there are three forces, but these three forces making different angles in different directions, right? See, R1 is in this direction, R2 is in this direction, R3 is in this direction, and these three forces are lies in different quadrants. It is very difficult to solve this problem. What we have to do, we are making it simple, like we are making them into two perpendicular directions. One is horizontal, one is vertical. If you make them all the three forces into simple form, we can calculate it easily without any complexities. That's why we are going for this method. Okay, so all the forces make an H component, that means horizontal components. Similarly, while applying sine, it makes an vertical component. Don't remember that cos is for horizontal, sine is for vertical. Here the main difference is theta. If theta is made with x-axis, then here the component become cos. If theta made with y-axis, then here it becomes cos. Okay, the side where the theta exists, based on that the component decides. It is a shortcut. Okay, if you are confused, you follow the actual method. Now, as combining all the three forces, we get horizontal component as H, vertical component as V. To make these two forces as a single force, we already know from the parallelogram law. What is that formula? P square plus Q square plus 2pq cos alpha. But as the alpha value here is 90 degrees, this part erases, right? Then what the remains? P square plus Q square. Similarly, H square plus V square. Okay, this is the simple way, and the direction also similar to that, which we learn in parallelogram law, V by H. Here I take P as V, Q as H, that's it. Remaining same, because vertical component, horizontal component. Okay, now did you understand this concept? If you have any doubts, please comment me below. I will explain it later. Now let's see a problem about this, then you can understand the concept clearly. Here, read this problem. Four forces of magnitude P, 2P, 3 root 3P, 4P are acting at O. Angles made by these with x-axis are 0 degrees, 60 degrees, 150 degrees, 300 degrees respectively. Find the magnitude and direction of resultant force. Okay, if there are two forces, you can easily find out the resultant of these two forces by using parallelogram law, right? But here there are three forces. How to solve this? There is another method. You can solve these two forces combinedly and you can find a resultant. After that, you have to apply parallelogram for this resultant force and this remaining force. You can get the new resultant. That will become a actual resultant force. But now you can do it is in a simple way by resolving the forces into x direction and y direction. See, this force makes an angle 60 and this 150, this is 300. All are making the angles with respect to x-axis only. Okay, now we have the formula similar to that formula. What is that? First force P into cos theta. What is the angle made by P with x-axis? 0 degrees, right? So P cos theta, 2P cos 60, 3 root 3 cos 150, 4P cos 300. Okay, by doing the calculations you got minus P by 2. Similarly V, sin theta, as it is a vertical component, so sin theta, so that becomes root 3 by 2 P. When you got horizontal and vertical component, what will be the resultant formula from the parallelogram law? Root of P square plus Q square, which is nothing but H square plus V square. So resultant will become P and the direction will become 120 because tan inverse of Q by P. Okay, So it is a simple method. You can do this method in a different way, because as the forces all are combinedly, you will get confused. You can do this with single force. How? First take the force P. To this force P, first find out the horizontal component and vertical component. What is the angle made by P with x-axis? 0 degrees, as it is a horizontal force. So 0 cos 0, P cos 0, as the 0 value is, cos 0 value becomes 1. So H equal to P. P sin 0, what is the sin 0 value? 0. So vertical component becomes 0. This make this as 1. Next coming to 2P. Angle is 60. So 2P cos 60, 2P sin 60. Coming to third force. It is 3 root 3P. Angle made by it is 150. Right? Here you can take whether it is cos 150 or otherwise, as it is total angle 180. 180 minus 150, how much it will be? 30. I am taking this force along this directions. Okay. As it is 30, it becomes cos 30 and this becomes sin 30. Right. This becomes cos 30 because theta is here. And it is along negative x-axis. That's why it becomes minus cos 30. It is positive y only. That's why it is plus sin 30. Do you understand? See carefully. I am not taking this angle. I am taking this angle. That means 180 minus 150, that is 30 degrees. And also I am resolving this force in these two directions. These two directions. As it is negative x-axis, I am making the component as minus. As this is positive y-axis, I am making this component as positive. Similarly, come to the fourth force. It is 4P, angle 300. I am not taking this angle 300, as it is a circle. 360, complete angle will be 360. 360 minus 300, remaining angle is 60 degrees. So I am resolving the force in these two directions, which is positive x-axis, negative y-axis. That's why I got the vertical component as negative, horizontal component as positive. As it is 60 degrees, the side which is along the side of theta, it will become cos, and the other side will become sin. As it is negative, minus sin theta. As it is positive, plus cos theta. That's why 4P cos 60 minus 4P sin 60. Okay, likewise you can find out the horizontal and vertical components individually for each force, and then combining all the forces, you can get H component, and combining all the vertical forces, you can get vertical component. So finally, similarly, you can apply the formula of R is equal to root of H square plus V square, and also direction will be tan inverse of V by H. Okay. See, both the methods are similar only, but in this method you are taking all the forces at a time, but in this method we are considering each force individually and you are making the components individually. And here we are considering the complete angle with respect to x-axis. Here I am changing the angle. It is with respect to negative x-axis and this is with respect to negative y-axis. Okay, based on that the signs of the components will be negative. Both are same. That's all for this video. In our next video we will discuss about moment of a force. Until now we see the only linear displacements or linear forces. In the moment, how the rotation will occur, that we will discuss in the next video. If you like my explanation, please like, share this video and subscribe to my channel and press bell icon to get notifications. If you have any questions, please comment me below in the comment section and we will discuss this in next video. Thank you.